Okay, next concept we are going to study is a real line. So a real line, real line. So you were seeing from the almost from the 8th standard, this line is called as a real line. So which includes the number from minus infinity to plus infinity, right? Here at the middle you can see that 0. So we are going to denote like that. Here it is 1, here it is what 2, here it is what 3, here it is 4, and here it is 5. Here it is minus 1, here it is minus 2, here it is minus 3, and here it is minus 4, right? So and it goes left side, so here it goes what right side. So here you can see that after that 0 all the positive numbers. So after that 0 there is all positive numbers, and this side after the 0 all negative numbers. So all negative numbers. Plus V means positive numbers, negative minus V means negative numbers. Just concentrate here. This real line is very much complicated and which is having a maximum properties. If you understand this, which is going to be easy for you in future, right? Okay, listen here. Here 0 is the number which is neither positive nor negative. After that immediately this we can see the line here. So this line represented by the numbers. Number means here this line is made up of small dots, which every dot represents one number. For example, after that you can see that after 0 I'll consider 0.1. After that 0 I'll consider there is a number which is 0.1. Now my question is there any number present between 0 and 0.1? Yes. There are infinite, or you can call that there are uncountable numbers are present between this 0 and 0.1. So here which are those numbers? If you ask me, I am going to tell you. After this 0.01 is also there, which is going to be what sat here, right? So now you ask me whether there are number between 0 and 0.01. Yes, there are infinite numbers. For example, if you take any two numbers on the real line, there will be always infinite number of rationals also will be present, as well as irrational numbers also will be present. So try to understand what I am telling you is. So I'll conclude and I am going to repeat the sentence again. On this real line, the numbers are sitting together very closely in the form of dots. That all numbers will form the real line. So my conclusion is so between any two real numbers there are infinite number of rationals also there are infinite number of irrationals also there. Between 0.1 and 0.2, if you ask me, there are again infinite, or you can call that uncountable number of rationals also will be present, as well as irrational numbers also will be present. So conclusions and statement is like this only. Between any two rational numbers you can find infinite number of irrationals also, you can find infinite number of rationals also, right? That all rational numbers and irrational numbers, together will form a set of the real numbers, which you can write in the form of Q union Q dash will form what set of the real numbers. You can see the real number on the board, which you can call it as a x-axis also. So here the real line will consist all the natural numbers 1, 2, 3, 4, 5 and so on. It consists all the whole numbers 0, 1, 2, 3, 4 and 5 and so on. It consists of all the negative natural numbers, all the positive natural numbers including 0, which means all the integers also there. On this real line all the rational numbers also will be present. All the real line there will be all irrational numbers also will be present, right? So I hope you understand. This is a real line. Every dot on the line will represent one number which may be rational or irrational. Between any two small number, there again infinite number of rationals as well as irrational numbers will be present, right? So clearly listen the audio, you are going to understand the things, right? Next concept in this in first chapter of your 10th standard is Euclid's division lemma. So I am going to discuss about now Euclid's division lemma. Euclid is the name of the mathematician who is also called as the father of the geometry, and this word lemma means it is a proven statement which is used to prove the another statement. मतलब समझो, so in mathematics you are going to see again and again lemma, as well as one more word you can see algorithm. So you can see that algorithm. These two words are derived from the books of the mathematician written, who is I think he is named algebra something is there. Lemma and algorithm, which are the most repeated words in mathematics you are going to see in future. Lemma means it is a proven statement, proved statement, which is going to be used to prove the another statement. Simple. And this algorithm means it is a systematic representation of some example step by step. So for example, you are going to solve a quadratic equation, so you are going to follow some steps. That particular steps followed by some method, that method is called as algorithm. Algorithm is simple method of a systematic representation of the problem, method by step, that is called as algorithm. This lemma means it is a proven statement which is going to be used to prove the other statements, right? So this is about lemma and algorithm. So now we are going to discuss about what this Euclid's division lemma says. Concentrate here. So I am going to write the statement on the board now. If A and B are any two integers, A and B are any two integers, then there exist Q and R such that you can write A is equals to BQ plus of R, where R must be less than B and greater than or equals to what? 0. So this is the exact statement of the Euclid's division lemma. Let me repeat again. If A and B are any two integers, then there exist Q and R such that A is equals to BQ plus R and R must be less than B and greater than or equals to what? 0. Right? So if you see the statement, so you can't understand easily, that I am going to explain what it exactly says. If I divide this A by B, you are going to get the quotient Q and the remainder R. Simple. If you divide this A by B, you are going to get the Q as the quotient and R is the remainder, that the statement says. Simply how to write it means A is equals to BQ. A is equals to BQ plus R. Simply, so if you follow this method, which will be easy for you to write every time. So how we are going to write? A is equals to what? BQ plus of R. So which is already written here. You can write it as A is equals to this into this plus of this. Right? So now I am going to tell what is this A. This A is called as dividend. This A is called as dividend, and this B is called as divisor, and this Q is called as quotient. And this R is called as a remainder. This R is called as remainder. Right? So this is the things. Still I hope that you not understood Euclid's division lemma, what it says. So by taking the example I am going to explain you. This is very much important. most of the students will not concentrate on this, but it plays a very much big and important role in solving the examples in future, right? Okay, let us see what it exactly says. If I divide this 21 by 3, if I divide this 21 by 3, you are going to get 3 7s 21. So answer is how much? 0. Then how we are going to write it? 21 equals to 3 into 7. 21 equals to 3 into 7. So then the remainder is equals to 0. How we are going to write it? 21 is equals to 3 into 7 plus of 0. So if you recalculate again, you are going to get it as what? Equals to 1 only, right? Just a minute. So next number I am going to take it as what? 22. Therefore how you are going to take it? So if you divide this 22 by 3, so 3 7s again 21. What is the answer? So remainder will be what? 1 again. How to write it in the form? Simple. How you are going to write it? 21 equals to 3 into 7 plus 1. So 22 can be written as 3 into 7 plus of 1, right? So if I divide 23 again by 7, so you are going to get 3. So again 3 7s 21. What is the remainder? Remainder is equals to what? 2 again. Therefore how we are going to write it? 23 is equals to 3 into 7 plus of 2. Therefore what? 23 is equals to 3 into 7 plus of how much? 2, right? So next one, if I take next number 24, what happens? So here 3 8s how much? 24. What is the answer? 0. How we are going to write it again? 24 equals to 3 into 8 divided plus of 0. Therefore 24 is equals to 3 into 8 plus of 0. Just you see here A is equals to here I will consider always this is the remainder, this is the remainder, this is the remainder, this is the what? Remainder. Here you are going to divide it by 3, right? Remainder starts from where? 0, 1, 2 and 3 will not come, right? So that is what I am trying to tell you. If you are dividing by 3, remainder may be from 0, 1, 2. If in the remainder again 3 comes, it will divide it again. Means again you are going to get remainder as 0. So my conclusion, what I am trying to tell you is, if you are dividing by 3, then the remainder may be from where to where? 0, 1, 2. If you are dividing the number by 4, what are the reminders may be? Reminders may be 0, 1, 2, 3. If you are dividing the any number by 5, what may be the reminders? 0, 1, 2, 3, 4, right? So here if you are dividing the number by 3, the reminders from 0 to what? 2. If you are dividing the number by 4, the reminders may be from 0 to what? 3. So if you are dividing by 5, then the reminders may be from 0 to 4. That is what I am trying to tell is. So here if you are dividing any number by r, so here if you are dividing any number by b, the remainder must be less than b and greater than or equals to what? 0. 0 से शुरू होता है, so b से एक number कम रहता है, right? So that is what Euclid's division lemma says. Okay, this is enough for today. So let us see in the next video.